Welcome to the demo recording for Sprint 1 of the SearchWorks Indexing and Performance Work Cycle. I am Christina Harlow, and I am the product owner for this work cycle. I'm joined by members of our team from across and beyond DLSS, including Chris Beer, who is our technical lead, Shelley Doljack, Jessie Keck, Jack Reed, Camille Vila, and Drew Wingate, who are our engineers on this project. We have Alyssa Hefele and Sarah Seastone as our key stakeholders, Gary Geisler and Jennifer Vine as consultant UX designers, Stu Steinman as our member of DLSS Direct and our direct liaison, and Cam Chan, as well as Julian Morley, joining today as our ops and DevOps liaisons. So this team has been pulled together to work on SearchWorks indexing and performance, hoping to make our SearchWorks index faster to build, easier to build, and to make the SearchWorks interface quicker to respond to searches and queries. For Sprint 1, we had a number of set goals that we set out to achieve in the last week. In particular, we wanted to continue our move of VMs to the new computing center, which our ops liaison will talk about. We wanted to be able to rerun our current indexing process to get better profiling data of the current state, which a few of our engineers will comment on the outcomes of that. We wanted to use the metrics and profiling data we were generating in order to understand and set some performance goals. How fast should we be aiming for? And I will give some information on that. And we wanted to set a lot of baselines for the various components being optimized. In particular, getting a lightweight relevancy changes framework and testing overview. And we are excited to show some work done on that. We wanted to be able to continue working on updating and improving our testing suite for the SearchWorks index test, and one of our engineers will give an update on that effort. We wanted to continue profiling of the index pipeline, in particular using our new Relic Pro account, which we're excited to have, and we demoed a little bit in our Sprint 0. And we wanted to also include beginning to write a simple conversion pipeline in our traject library, which is a possible library we'll use in the future for our new indexing pipeline. We wanted to get that written so we could compare it against what's actually running now and make sure we're going in the right direction. So with that introduction, I'm going to pass it over to Jack, who can give an update on the profiling of our current system. All right, Jack, do you want to share your screen?
Yep.
Cool.
Okay, so over the past 2 weeks, we've been running various iterations of indexing runs. The first of these was to get a baseline of what our current indexing code and process does and how long it takes. Not only from the indexing code side, but also from where Solar lives. So we've run 6 different iterations of indexing runs, and our first indexing run took 16.5 hours, and previously we had said marc indexing takes 8 hours to run, and so I'm not sure what the we didn't have any data from that. We didn't actually have log data from that created, but so to show here the previous 8 hours, the first indexing run we did 16.5, and to the last indexing run we were able to finish, I believe, in 93 minutes. And so we've taken a 16-hour process or an 8-hour process down to 93 minutes, which is really exciting. There haven't been really any code changes except inserting some ands and some bash scripts. There have been increasing CPUs on various machines, and then also pinpointing kind of network issues in the pipeline and isolating network issues to increase performance. So through all these different iterations, we were able to change different variables and get our indexing speed down quite significantly. So we made some charts. So we have lots of different data about all these different indexing runs, and we've now created memes for this. So that's been, I guess, in 2 weeks, we've been able to see 16 hours to 1.5 hours. It's been pretty exciting to reduce that down with just minor changes.
Great, thank you very much. And thank you for that meme, that makes it a lot better.
You're welcome.
All right, so passing over now to Cam to talk about our ongoing NDCCH move and other ops work going on to support this effort. Cam, do you want to share your screen, or are you okay just speaking?
I'm just okay with speaking.
All right, yeah, that's great.
I'm going to share it. So I'll continue to move the a bunch of search work related servers from Foresight to NDCCH. And last Thursday we were done with most of the search work ones, and there were a handful of them that I had some question about before moving them. And this morning, after talking to Jessie about the search work MySQL machine, we decided that this Thursday, maintenance window, I will be moving the search work MySQL production servers during the maintenance window. And then there's 5 of those search work web app machines that I started them in the background, and I'll be moving them this afternoon. So those 5 should be done this afternoon. And Thursday again is the MySQL ones. And after that, there are some potential machines that we could move, but the main ones will be done after this week. So that's where we are.
Great, fantastic. Thank you so much, Cam. All right, now we're going to go into some of the baselines we tried to set for what we were aiming towards fixing. There are a lot of different components and numbers and metrics from our end-to-end indexing system, so we wanted to try to get some scoping and ideas of what we were aiming for in repairing this. I wanted to point out really quickly, looking at our project board, which was shared out in Sprint0 and will be shared out in the comments for this video as well. Thinking about what metrics we were looking for to aim for with our performance goals, other than just making it faster. Thinking first also about the indexing creation act, so we're not yet to the application response time performance. We wanted to try to get all of our MARC and then possibly all of our mods data done within 1 business day in order to support whoever was running the data pipeline to be able to follow up on errors pretty quickly. And so towards that goal, we were thinking about trying to get 9 million or more MARC records, which is, our current catalog, I believe, has something like 8.6 million. So 9 million MARC records indexed in about 5 hours. So this is from the ILS to our SearchWorks index. We were also thinking about trying to get our 1.6 or so million DOR, which is our digital repository, mods XML records, into the SearchWorks index in about 2 hours. And we put some numbers there for what kind of partial sizes and performance times we were looking at, based off of the common size of jobs going through our indexing pipelines now, and the kind of response time we might want for the users who are kicking those off and monitoring them. I will say with Jack and the team's work in the last week, we're well under doing a full end-to-end index of 9 million MARC records in 5 hours, but we're giving ourselves some wiggle room in case we need to balance simplicity of the code and the systems against just pure speed and getting the data through. So this makes the system not just fast, but also easier to extend and monitor and keep up to date. So that's what we're aiming for performance goals. I'm going to hand this off now to Shelley to talk about some of the test suite in additions and enhancements for our MARC index. Shelley, would you like to share your screen?
Yep.
All right, so let me stop.
I think this is it.
Great.
Okay, so this is our repository of tests that we run against the index called SearchWorks Index Tests. And I created a bunch of issues in here that are for feedback that we got for relevancy in SearchWorks. I got a list from Alyssa of the tickets that we have in JIRA that are related to relevancy ranking, and kind of replicated these issues in our GitHub project. And I'm going to walk through two of them that I addressed in our SearchWorks Index Test Suite. This first one, I basically copied the main part of the ticket from JIRA into this GitHub issue, leaving out some identifying information of who submitted the feedback. So this first one, part of creating or writing these tests is also trying to figure out what it is that the person is doing with this type of feedback that they leave. So this one here, the person did a search for historical abstracts, and in the databases facet. And here we have a link to what their search, the page that they left the feedback from. And we see that it was a search in the databases facet for historical abstracts. Oh, whoops. I'm having issues here. The pull down menu came up. Okay, there we go. So, so they did a search for historical abstracts in the databases facet, and they expected to see that when it's sorted by title, they expected the historical abstracts database to show up first, even though it was sorted by title. But it shows up 6th here. So going back to trying to figure out how do we write a test for that, when I was looking at the test suite, we had a spec for sorting, but we didn't really have a test that tested whether title sorted properly, alphabetical or not. So I took their search that they did for historical abstracts in the databases facet, and I said to sort it by title ascending and then descending, and compared that the first and last ID on the response were the same. And then that it also, the title for the first record that comes up for that search was not historical abstracts, because we know that when it's sorted by title, it's going to start, the result is probably going to have a title that starts with A instead of H. Mm-hmm. Another issue with relevancy that came up in the feedback that we got is when someone does a search for a digital collection record, the homebrew computer code collection, it ends up coming up as the 33rd hit in the results instead of first. The person is expecting to see the digital collection record appear above all the child records. So, for instance, this is this person's search in SearchWorks. They search Homebrew Computer Club newsletter, and you can see, I'm going to scroll down, these are all the child records for that digital collection that came up first. and we scroll all the way to the bottom, near the bottom, and we see the digital collection record. And there's various reasons why the child records are coming up first in this search. So this is our current relevancy, and the user is saying that the current relevancy is not what they expected. And so I wrote a test for this user experience and marked it as pending here. I say pending, fix me, because it's not exactly what the user is expecting. But I am capturing the fact that when someone does a search for Homebrew Computer Club newsletter, they expect the title of the digital collection record to come up first. So that's just a few examples of some of the tests related to relevancy that are getting added to our test suite.
Great, thank you so much, Shelley. That was very nice to see. So let me go here. And the next thing we're going to have spoken about is Chris Beer is going to talk a bit about some of the issues we're investigating as highlighted by that test suite. Chris, you're going to share your screen, I imagine?
I am.
Great.
Okay, so last week we mentioned that we built a new SearchWorks index on our upgraded Solr machines. One of the first things we did is a smoke test using these relevancy tests that Shelley just talked about to compare the test failures from our current production collection. And I believe we now have 3 failures in that test suite due to changing data. If we compare that to our Solr collection, we can see we now have 280 failures of a variety of tests. This week we did some analysis about these failures and broke it down into basically 3 different failure modes. The first is an issue that we knew going into the project, and that is Solr has changed the way their Boolean searches work between our current version of Solr, Solr 4, and our new version, Solr 6. There's a lot of discussion on various Solr and Lucene tickets about the behavior. The long story short, it was a weird behavior to begin with, and it's a different weird behavior now. So there's going to be certainly some discussion about the correct behavior and ways to mitigate impacts on the users. The second source of error is a large number of failures with Chinese, Japanese, and Korean characters, especially when those searches cross field boundaries. An example of this is an author title search. And we dug into this issue because it was surprising and disconcerting. And we believe upgrading Solr from 660 to 661 will address this issue. There were some changes to the way minimum match works that particularly impacted these cross-field references. A third source of errors is just general document ranking changes. We have a lot of tests that check things of the style, a user enters this query and I expect to see this document in the top 3 or top 5. And there have been some changes in Solr that have changed the way those things rank. Kind of two of the big ones is a switch in the way the similarity metric is calculated. It used to be calculated based on the total size of the corpus, and now they restrict that to the number of documents in the corpus with that particular field. This has the result of boosting unique matches in lesser use fields more than generic matches in a field that every document has. A second change was in fielded search requests, so searches for a series, subject, author, etc., where our relevancy is more like a Boolean than it is a full text result. So it happens these 500 documents are in the search result, or have a particular series, but there's no real way to rank them based on relevancy. It's a Boolean indicator saying, yes, it absolutely was, and there's clearly a difference in how Solr returns those results natively. So with these three issues, we're going to be taking these and presenting them to our super users group to validate whether it's a good change, a bad change, or something that needs to be further addressed. We've also begun to gather more information about the relevancy changes. So last week we created this Relevancy Dashboard that collects real-world user queries. We gathered data from about a month and a little bit, and did a comparison between what we have now and what we have in Solr without addressing those three issues I just mentioned. The good news is about 80% of our queries are completely unchanged. They're result for result identical, with then a long tail falling off with things that have changed quite a bit. So we've gathered this information. We've started to construct kind of an artificial, what we're calling a change score, to kind of indicate the severity of the change. I'll click through a couple of these so we can get a better idea what that means. For this document, our most changed document, we have a user that's entered a query search for a known item, and we can see the known item pops up first in both result sets. The big divergence between the new and old Solr is the number of results that are returned that are not that known item. So with Solr 6, we get 6 results. With Solr 4, we were getting 115 fairly low quality results. A kind of middle tier example where things go different is this keyword search for the Japanese on trial, where again we have a known item search, it seems, followed by several documents that are potentially related, and we're going to be looking to our super users group to determine how these, whether the shift in these documents is appropriate or not. Kind of looking at it from a naive view, it seems the new set of documents is perhaps more related to the Japanese on trial than the old one, but we'll look to our experts to determine this. On this particular search result, we can also see a feature we had to just express the shift in documents. So we can see this second document has shifted down one place and is now the third most relevant document. And on the other hand, this document that was about 10th has shifted up 9 places to be second. And we can dive into some of this advanced Solr relevancy information to see just why that is. And I'll show off the third case where not much has changed at all. And so it has a very low change score. There's search for Banksy, has most of the documents basically in the same position with a little shifting here and there. So we're looking forward to digging into this information to make better decisions about our relevancy.
Great, thank you, Chris. And I will say that the information that's coming off of that dashboard, like Chris said, we are trying to hand off to super users. So as part of this last sprint, we've set up a lightweight process for gathering data from various analytic sources like the test suite that Shelley showed or the relevancy work that Chris showed. Putting it together, having a staging environment where SearchWorks with our changes will be running, and then asking identified super users from our libraries community to take a week, test the new index, test the staging environment, look at the identified areas of change, and give us feedback on whether it was good or bad. So we can gather the quantitative data relatively easily, but the qualitative data requires expert review. So we're excited to have that in there. All right, as our last thing we're going to show for the demo for this work cycle, I'm going to hand it off to Jack to show our simple traject pipeline work, and this will foreshadow some of our future work. Jack, do you want to share your screen? Great. Nope. Jack, are you ready?
Sorry, I'm having issues.
Mm-hmm.
Okay, so we talked a little bit earlier about our performance with our current Solr SearchWorks indexing code base. One thing about that code base is it's a deprecated Java code base, so it runs in a version of Java that's not supported anymore. And so one thing we wanted to do was explore new technologies to see if we could replicate or even improve speed results. So one thing last week, we started to run some base benchmarks on using a technology called traject, which was actually written by many of I think several of the solrmarc contributors. And we had some really promising results. So running traject code against our marc data with the same fields to be indexed, we saw in the solrmarc code we were getting around 775 records a second indexed. When switching that to traject using Matt's Ruby interpreter, we were able to get around 2,400 records a second. And then switching that to using JRuby, we were able to get, where is my JRuby? we were able to improve that to 3,500 or 3,400 records a second. So this was really kind of a promising benchmark last week. And so based off that, the team embarked on porting over the basic solrmarc SearchWorks indexing code into traject, keeping intact the solrmarc SearchWorks unit tests. So that work is still in progress right now, and when that's completed, we'll be able to provide future performance testing on a larger scale.
Great, thank you so much. So with that, it wraps up our demo for Sprint1. As you see, we've got a lot of progress made, and we hope next demo, we'll be talking a little bit about where our Solr index will end up for SearchWorks, what versioning issues we're going to try to aim, or what version we're going to try to aim for Solr, and continue along the lines of inquiry and work we've highlighted here. Thanks for joining. As ever, communication links are in the notes below this video.